Hello student, let's solve question number 4. Two identical charges plus q each are placed at a distance 2d. So suppose the charges are here plus q and another plus q charge is here. Okay, the distance between them is 2d. So the distance between them is 2d. Okay, a test charge free to move on perpendicular bisector of the line joining the two charges. So this is the line joining the two charges, and suppose this is the perpendicular bisector on the line joining the two charges. Okay, fine. Now a test charge free to move on the, okay, if test charge is free to move on this bisector, right? Good. The test charge will feel maximum force when it is at a distance from midpoint of line joining the charges. So the midpoint joining the line of the so this is, suppose the point is O, and we have to find the distance. We have to find the distance. Suppose this is the position point P. Okay, if the test charge is situated at point P, then it will feel the maximum force. Okay, maximum force. Now we have to find the distance of point P from point O. Let the distance be D. Sorry, not D, because D is already mentioned for 2D, right? 2D is the distance between the two charges. So this distance is D, right? This distance is D. Suppose the distance of P from O is X. Okay. Now we have to calculate the net force on the test charge at point P, and then we will maximize. We will find the condition. We will put the conditions on the uh, force, right? Maximizing, we will maximize it. So the force exerted by the point charge q plus q, the left, which is situated at left, this force will be in this direction. Suppose the force is F. Similarly, this equal amount of force will be exerted by the this plus q charge, and that will be in the direction, in this direction F, right? Now if we say that this angle is theta, and let's draw a line here, then this will also be theta, right? So you see the e cos theta components of the both the force, sorry, F cos theta components will be cancelled out, and the perpendicular normal components will be added up. That is, the net force will be 2F sine theta on the test charge at point P. So now write 2F sine theta is the net force, correct? So 2, what is F? F is nothing but the QE. Q is the test charge and E is the electric field due to individual charges. And what is sine theta? Sine theta, you can see, suppose this point is A, then from triangle you see, from triangle AOP, you can write that sine theta. Sine theta means height by hypotenuse. So height is x and hypotenuse is nothing but root d square plus x square. So write here x by root d square plus x square. So this is sine theta. And what is the value of E? Okay, E is nothing but K. Okay, write it as Q prime. And when the value of E is K Q by R square, what is R? R E is the AP. That is d square plus x square, root of d square plus x square, and then R square, right? So this is E, and then x by root d square plus x square. Okay, okay. Now I would like to erase this sine theta because this is not going to help anymore. Okay, here 2k q prime q, and then we have x by d square plus x square whole to the power 3 by 2. This is the net force, right? And now we have to maximize it. The condition for the maximum force experienced by the test charge is df net dx will be 0, right? So you see here these things, these terms, these quantities are constant, right? So after derivative, these things as the derivative will be 0, so these things will when this will go to the right side, there will be 0. So we will find that finally d dx of this part that is x, we can write it as also d square plus x square whole to the power minus 3 by 2 is equals to 0, correct? Okay, now suppose it is the the rule is UV condition. So suppose x is constant and we will take the derivative of d square plus x square whole to the minus 10 by 2. So you see minus 3 by 2 will come up here and d square plus x square whole to the power minus 5 by 2 will be there, right? And then this part, the second part will remain constant, that is d square plus x square whole to the power minus 3 by 2, and derivative of x, which is nothing but 1, is equals to 0, correct? Okay, we have any mistake here. A 2x will be there into 2x because here x square, there was x square not x, so 2x. So now what will be the next line? See, these two will cancel out, x and x gives x square into d square, here a 3 is there, d square plus x square whole to the power minus 5 by 2. A negative sign is there, when this term will go to the right side then this negative will not be there, so this will be d square plus x square whole to the power minus 3 by 2, right? Okay, so some cancellations will be there, and finally we will have 3x square into d square plus x square whole to the power minus 1 is equals to 1, and we'll have 3x square is equals to, this will go to the right side if this part d square plus x square whole to the power minus 1, if this part will go to the right side then it will become d square plus x square only, and we will have 2x square is equals to d square, and then x is equals to d by root 2. So this is the position where the force will be maximum. Okay, so the correct answer is option 3. Okay, finally we have to remember this result. Okay, we can't derive the data, we can't derive the answer in the examination hall for competitive examination, right? Okay,